Today, lesson 15C, day number 2 of volume. Yesterday, our focus was mainly on reviewing the finding of volume in cones, cylinders, and spheres, and then we extended it out to complex or composite shapes. Today, we're restricting it to where we may have to find a radius or height or a diameter of one of those shapes. So let's just go ahead and get started. A little bit of background knowledge. Whenever we solve equations, we're trying to find the value of the variable to create a true statement. And the reason why I'm reviewing this very quickly is because if we need to find a radius, this is what we're going to end up with. So the idea here is we want to get w squared by itself by multiplying both sides of the equation by 5, and then take the square root of both sides. And remember, when we have some value of an equation squared or some value of a variable squared, if we're just solving an equation, we're going to end up with the plus or minus the positive or negative version of that. So in this situation, we end up with plus or minus 10 square roots of 6, because if we can simplify the square root, we should. And then if we have cubic equations, we still want to get the variable cubed by itself, in this case dividing both sides by 1.6, and then take the cube root of both sides. And you had one similar to this in the homework last night, and what I want to make sure of is that if you don't end up with a perfect cube like you do in this one, so for example, let's pretend for a second that you ended up with f equals the cube root of 25. If it's not a perfect cube, then we can just leave it like this. Now the reason why this became this is because 64 is a perfect cube. So if we don't end up with a perfect cube, and the one in the homework you didn't, we just make sure we leave our answer like that. Okay? All right, so let's move on here. This is a problem that, is this in your notes? Yes, it is in your notes. And this is a problem we did probably about 2 or 3 weeks ago. The volume of the cone below is 235.5 cubic feet. What is the length of the radius? And I'm telling you at this point we can use calculators. So when we use the formula for the volume of a cone, which is volume equals 1/3 pi r squared h, where h is the height or the altitude of that, we plug in everything that we know. We know that the volume is 235.5. We know the pi, we estimate it to be 3.14. And the height or the altitude of that cone is 9. And then we do some simplifying where we can. We end up with this. Now sometimes we want to multiply both sides of the equation by 3, but we didn't need to in this one because of the fact that the radius here, or excuse me, the height here, and the denominator here, we could do some simplifying there. So at this point, we divide both sides by 9.42. And then we end up with r squared equals 25. Take the square root of both sides. Now we end up with a radius of 5 feet. Now if we were just asked to solve the equation r squared equals 25, our solution would be plus or minus 5. But of course, a negative radius doesn't make any sense. And so that's why we neglect the negative version of our answer. Okay? So this is something that we have done in the past. Let's go to the official number 1 for today. The volume of the sphere below is 904.32 cubic meters. What is the length of the diameter of that sphere? Remember, to find the volume of any sphere, it is volume equals 4/3 pi r cubed. Go ahead and give it a shot. In this problem, we know that the volume is 904.32 cubic meters. We know the pi is 3.14. We don't know what the radius is. That is what we're trying to find. And at this point, I would multiply both sides of the equation by 3 just to get rid of the denominator on the left-hand side. Now remember, when you do that, you're not multiplying the 4/3 by 3 and the pi by 3. You're multiplying that whole thing by 3. And I will quickly review that idea again in just a second. But this is what you should end up with. And then multiply the 4 and 3.14 together, then divide both sides by 12.56. And we're going to end up with r cubed being equal to 216. We take the cube root of both sides, and we end up with the radius of 6, but we're not asked for the radius, we are asked for the diameter. Okay? Okay, so continuing on here, this idea of clearing up the idea of multiplying both sides by 3. Now, I have talked about this before, but I remember when we did this before, there were a few people who thought that on the right-hand side you would multiply each part by 3. So then what happened was I brought up this example right here. If you multiply both sides of 2 times 3 times 4 equals x by 3, you are multiplying each part by 3, not 2 by 3 and 3 by 3 and 4 by 3, because look, let me back up here. If I multiply both sides by 3, this side obviously right now is 24. So if I multiply 24 by 3, I end up with 72. And so now I have to multiply this side by 3. So you're not multiplying each part by 3. 2 times 3 times 4 is one product. So when you have one product, you're just multiplying the entire thing by 3. And so just make sure that when you are multiplying this side by 3, this is like 3 times 4/3 times 3.14 times r cubed, not each part independently. So make sure that you, when you do something like that, that's what you're doing. Yes?
For number 1,
Getting back to this multiplying by 3, at least in this one, it should be fairly easy because you're multiplying this whole side by 3 right here, and what happens is those 3's cancel out. So 3 times 4/3 is 4. That's where I got the 4 right there. So you just have to be careful there. Okay? All right. So hopefully that is now cleared up there. Let's go on to number 2. It says a company is going to redesign the cylindrical container it uses to market its product. The volume of the proposed container will be approximately 42.4 cubic inches, and the diameter will be 3 inches. What will be the approximate height of the cylinder rounded to the nearest tenth of an inch? Go ahead and give it a shot. All right, so when I walked around and when you were shoulder partnering, I think I saw everybody that I saw had the correct answer except for the way that they had their answer written. Okay, if it says to round to the nearest tenth, you need to have a digit in the tenths place. And I think what's happened over time is some of you have misinterpreted what you were told, or perhaps in one of the lower grades you may have been told incorrectly. So what I'm saying is I'm going to go through here. If the diameter is 3, that means the radius is 1.5, which is what we need. And then I went ahead and squared 1.5 multiplied by pi, and that's why I have 7.065 on the right-hand side. Divide both sides by 7.065, and you end up with something like this. H equals 6.00141543, and so on. Depending on the calculator you used, you may have had more digits than that. But we're supposed to round to the nearest tenth. That means the height rounded to the nearest tenth is not 6 inches, it's 6.0 inches. And I know some of you are thinking, yeah, but isn't it the same thing? Yes, 6 is equivalent to 6.0. But if we're asked to round to the nearest tenth, we need to have a digit, even if it's 0, in the tenths place. Okay? All right, let's move on. Number 3, we have a cone with a height or an altitude of 2.5 inches and a volume of 65.42 cubic inches. What is the radius of the cone? We're supposed to round to 2 decimal places, which of course means to the hundredths place. All right, so in this problem we are looking for the radius rounded to 2 decimal places. So volume of a cone looks like that. Substitute in what I know. And then of course, I'm going to multiply both sides by 3, which will then give me something that looks like this. Divide both sides by 7.85. And then, of course, I need to now take the square root of both sides. And it should be 5.00 feet for the radius. So questions with this problem? Yes, the units are not in feet. It's clear right here. We're talking about inches, so this should be inches. All right, let's go to number 4. In fact, right now, here's what I want you to do. I want you to do number 4 and 5 with your shoulder partner. And then we'll come back and we'll check those, and then we'll deal with number 6, and then we'll be finished for today. So go ahead and do both 4 and 5. Compare what you're doing with your shoulder partner as you go. Okay, I'll get back with you in about 3 minutes. All right, so number 4, we are looking for the height or the altitude of that cone, which I know it's a conical container, but essentially it's just a cone. And so we know the volume is 200. We know that the radius is going to be 4 because the diameter given within the problem is 8 inches. And so I'm going to multiply both sides by 3 right off this, at the beginning there, just so I don't have to worry about it. And then I end up with something like this, and then divide both sides by 50.24, and that would give me, rounded to the nearest inch, would be 12 inches, because we're rounding to the nearest inch. Now, the one where you have to do a little more thinking. We have a bowl in the shape of half of a sphere. That's what a hemisphere is. And so we would end up, you have 2 choices here. I said, well, if it's a hemisphere, then that means it's half of a sphere. So I dealt with it like this. Another thing that you could have done instead is you could have pretended, for example, that this is a sphere. So if the hemisphere has a volume of 225, a whole sphere would have a volume of 450. And if you think about that, that should make sense. And so if you dealt with it like that, you would end up with something like this. So either direction is okay. And if you think about it, if you take half of both sides of what I have in purple there, you end up with what I have right here. So it doesn't matter which direction that you go. But I'm going to keep going with the way that I started it. And so at this point, of course, I would multiply both sides by 3. And I end up with this. And then I multiply 2 times 3.14, and I end up with this. And then I divide both sides by 6.28. And that would give me the fact that the radius cubed is equal to, as I move this up a little bit, radius cubed is equal to 107.484076. Now if I take the cube root of that, I end up with a radius of this. Now I now understand why some of you were 1/10 off from what I got. And that's because you rounded the radius at this point. Listen, do not round until the very end. Okay? So now if I take that and double it to get the diameter, then I want to round. So now I totally understand how some of you got 9.6 for the diameter. You rounded and then doubled. You should not do that. You should double and then round, so the actual diameter should be 9.5 centimeters. And I'm just making sure that I do have the right units in this one, and I do. Okay, any questions about number 5? There's a lot going on in that problem. All right, our last problem for today. It says the height of a cylinder jar is twice the radius. When the radius of the jar is represented by x, and I haven't switched over yet because I know a couple of you are still copying some stuff down. When the radius of the jar is represented by x, what algebraic expression would represent the volume? So with number 6, I want you to work with your shoulder partner and come up with an algebraic expression that would represent the volume if the height is twice the radius and the radius is represented by the variable x. I'll give you a couple of minutes. So the height of a cylinder is twice the radius, and the radius, when the radius of the jar is, the radius is represented by x. So we want to write an algebraic expression to represent the volume. So we start with the volume. Remember, the radius is x. If you didn't get this, you should write this down. And the height is twice that. That's what it says within the problem. So in my volume formula, I'm going to substitute x for the radius, and I'm going to substitute 2x for the height. And when I do that, I end up with something like this. But now I need to simplify it. If you had got an answer to a problem that was 4 times 6, you would not leave it as 4 times 6. You would simplify that to 24. If you got an answer to a problem that was w cubed times w squared, you would not leave it like that. You would simplify it to w to the 5th. So here we have some terms that we can multiply together because of the same variable. X squared times 2x is 2x cubed. So what I'm saying right here is that this times this becomes 2x cubed. So we have pi times 2x cubed, and the way that we really usually write that is like this, 2 pi x cubed. So that would be the algebraic expression to represent the volume. And that was a bit of a challenge problem, but it should not have been too bad. All right, we are finished for today.